Okay. So, earlier this week, I had told you we had done a couple little lessons, or a little pre-teach of fractions, and we turned them into decimals, and I told you that it was a pre-teach of lesson 17 and 18. Well, kids, lesson 17 is here today. There are a couple parts that are going to look confusing, but if you bear with me, and I swear upon all that is holy, if you do not ask questions and you don't understand and you don't ask questions about something, I can't help you if you don't ask me. You have to ask if you don't understand. If you don't ask me, I don't know if you don't understand. If you don't ask. If you don't say anything, I'm going to assume that you understand. Because I do a whole lot of okay and yeah and all of those with my inflection, my inflected question of are we good? Kind of, and, oh yeah. And so when you're saying that, I'm assuming that you get it. And the whole purpose of these videos, that when I pull it up and I see there's one view, 5 views, there's 48 children, and there's one view, 5 views, that these videos are not really being used to their full potential. So it makes me again think that you really understand it, that you really truly get it. So in class, when you're saying yeah and you're not watching the videos, I'm going to assume that you get it. So you need to prove it when you're taking the tests, when you're taking the quizzes, Ryan, Nathan, that when you're following through, when you're doing the things where it's most important, that you're actually following through with everything that we're doing in class. If you don't understand it, you need to let me know. You know, if there's something you don't understand, you do have to ask. I'm not going to bite your head off. So, you know, I know that there are going to be some parts that when we first start, it does look confusing, but, you know, that it all ties together. I know the diagrams do look weird, but it's really, it backs up what we do in math. It goes with what I did in elementary school. I show you, I teach you what I did in elementary school. I teach you what your parents learned. Because what your parents learned is what I learned. I'm not that much older than they are. So, it's all the same. It's not that different. So the pictures just make it look weird. It's not that different. It's there to back it up. Sometimes we try to make you think, and I know that thinking is and it's scary. So right now it's relating decimal and fraction multiplication. You've done decimal multiplication. We've done it. You multiply 2 numbers and you bring in the decimal. I'm up here, buddy. I don't know why you're back there. Why are you looking back there? We're up here. Nothing good enough. Nothing good enough. Say the excuse. I'm up here. Don't. So, just backtracking. If we have 1/2 times 1/4, it's 1/2 of 1/4. You just multiply straight across. 1 times 1 is 1. 2 times 4 is 8. 1/2 of 1/4 is 1/8. So, easy peasy. And then the non-unit, which just means your numerator is not 1. 3/4 of 1/2. Again, you still multiply across. That doesn't change at all. 3 times 1, 3. 4 times 2, 8. 3/8. Still the same. Your numbers get bigger, steps stay the same. Then we moved up to, this was non-unit times a unit. We're just naming the fractions, what kind of fraction it is. When I was, back in my day, we didn't really know what kind of fractions they were. It was just like, okay, multiply that. That's all it was. So now you guys know what these fractions are actually called. And so now it's a non-unit fraction times a non-unit fraction. Again, unit fraction is just when it's got a 1 in the numerator. 2/5 times 2/3. Still, multiply across. 2 times 2, 4. 5 times 3, 15. 4/15. Steps stay the same. Numbers just got bigger. That's all. No difference at all. So, everybody good still?
Yes.
Okay. Yes. Okay. So, writing the fractions as decimals. How do you say it?
Point.
How do you say this? 1/10.
Oh.
1/10. I didn't say how do you say it as a decimal. I said how do you say it? 1/10. So if I were going to write this as a decimal, it's important to kind of know your place value. It makes it easier sometimes to know your place value as a decimal, or even know your division rules with powers of 10, if you want to think about it that way. Because when you're writing a fraction, it's division. 1 divided by 10. Do you agree that that's what this is? Because at one point, one of our tests was write fractions as division. 1 divided by 10. Well, if I have 1 and I'm dividing it by 10, where is my decimal here?
In front of them.
Regularly, normally, every day. Behind it. After I divide it by 10, Mr. Dull, it goes 1 spot to the left. That's why it becomes 1/10, because I divided it by 10 and it just went 1 spot to the left. If you just can't look at it and go, oh, 1/10, oh, 1/10. If you really need to know how it got like that. If you just can't look at it and go, oh, 1/10 is 1/10. Some people need to know how it got like that. Some people just know, oh, 1/10 is 1/10. Some people want to put a 0 in front of there, in front of that 1. Why is there not a 0 in front of that 1?
Because it's a 10.
It becomes hundredths. If you have this, that changes the value of that 1. You have to know your place value. This is tenths. This is why I told you not to throw away anything in those sheet protectors. If you have a hard, because aren't the fractions written on there too? The fractions and the decimals. Use it. This is tenths. This is hundredths. And then I think even over it, it's got this, doesn't it?
Yes.
Uh-huh. Why Miss Strickland told you not to throw it away, because I knew you were going to need it again. Yes, sir. You can. Very good question. I can put this. Does this change the value of the 1?
No.
No. It's just saying that there are no 1s. 0 wholes. 0 units. There are none. 0 in the 1's place. But there's 1 in the 10th place. Good question, Jaden. Yes. I can put zeros so the cows come home back there. I can put zeros all day long in the front. But the only thing that has any value is that 1 in the 10th place. Yes? No? Because the zeros have no value at all. They're just saying nothing's there. Nothing is here. Nothing is here. Yes. Nothing is here. Nothing is here. Yeah. Oh, so hold on. So if I had like how about this? Okay. So if I had 23 hundredths, because your value takes the place of the last number behind the decimal. Yeah, if that's because your value takes the place of the last number in the back. You're remembering what we did in first quarter? I hope so. Your value takes what's in the back. So then that would have to be okay. So, but you're making the numbers really big because we weren't going over 100. Not today. Okay. So, let me clear this off. Because I don't want to look at the problem set yet. If I have, remember this 0 in the front has no value, it's just there. Just saying that there are no 1s. But there's 1/10. I'm putting it there because you're going to see it. You might see it on tests. So you need to be used to being able to see it, that there's nothing in front of the decimal. Times 4. 1/10 times 4. Okay? Kind of like this, and you're like, never mind, I'm putting down. Okay? What would you do?
I would times 4 times 42.
So, one strategy that they've got us doing, and it's kind of more work, but this is a strategy that they've got us doing, is actually turning this into the fraction. Back into a fraction. Is that what you were saying? Because that's what we're doing this quarter, is multiplying fractions. Turning this into this. 1/10 is 1/10. Because aren't we like rocking this right now? We should be, because we can do this. It's what? 1 times 4 is 4
10.
over 10. 4/10. 4/10. Doesn't that sound like 4/10? 4/10. Now, is this how I would do it? No, because I'm old and I can figure it out a whole lot quicker.
Yeah.
But that's not how I'm going to teach you how to do it right now. So, so what if I have 0? Let me move that. What would I do for this, Cheyenne?
Well, I mean, I know that you can just do the 1 times 6 and make it 0.01. I mean, 0.06. But it's not that's just 6.
Right. So this one, how would you say this?
100.
100, because it's in the hundredth place, times 6. So multiply across. 1 times 6 over 100. 600. Again, if you've got a better way to do it that way. Because the way that they're going to have you do it, Dawson, the way that they're going to have you do it on the problem set and stuff, when you look at it, your eyes are going to go, "Woo," like the masks are going to poke out of your head and then come back in. Because again, remember, the way that they do it on Engage is they start really big and then they work their way down. They start big and work their way small. To where it's like they confuse the mess out of you and then they work their way, you go, oh! So they're showing you how it works, why it works, where it kind of confuses you a little bit, but then when they get to the, what I kind of call the old school way, you go, oh, this is so easy. So, me, I get it. I would never do it this way because I was taught a different way. So, this is just one way to do it. Because the one thing I like about this is it's showing you multiple ways to do it. Do you have to do it this way? No, but you do need to be open to more than one way to solve a problem. Because one way doesn't always work. One way can't always be, my way or the highway, because sometimes that highway is closed. So, I get it. I see it. It's more work, but it works. So, what they're going to do is, today is kind of like what we did with the rectangular model, where we did the splitting it up, and then we did the cross section the other way with the double shading. Okay? Not my favorite, but I got it. I understood it. Okay? So we're just going to introduce it today, and it's showing the background, how it works. Harder, because you got eyes in the back of your head. It shows how it works, why it works, and it's kind of like explaining this, why it works. Okay? Am I going to force you to do the squares the whole time? No, you're going to be like, oh, thank you God, Miss Strickland. Thank you. It's just showing you why it works. Okay? So chill before you start freaking out. I'm going to make you do these squares. It's just explaining it. Okay? Because we'll be here all day long if you're going to make me draw 100 square. Because it's going to be like hundredths and tenths. So you have to do blocks. We'll be here all day drawing these things. It's just explaining it. Okay? So before you freak out and start wanting to have a lynch mob coming at me with pitchforks and stuff, calm down. So you're going to take a breath and calm down? All right, so chill out for a minute. So I'm going to give you, I want you to look at A. Now A they already did for you, but I want you guys to stop working and I want you to look at A with me. Now A should look like the rectangular model that we used to do. And Emily, you're kind of looking at me like, no, it does not. You gave me a scowl face. So if you look at it, we've got tenths. How many sections do we have going up and down? 10. So it's divided into tenths. So what they did was they colored in 1/10, and that's where they've got 1/10 right there. She's like, I know, stop talking. Why? You gave me a scally face. That's why I'm talking. Then they've got times 1/10. So then they did the tenths going this way. So they did the cross section going left and right, going that way. So then the 1/10, that's when they did the double shading. See, yours just came in a darker color, but mine was in blue. So here is the one spot where it's the double shading. Yes, ma'am?
Like, is it, whenever I draw them, I'm like, which one do you do to put, to do the thing on the, to do the bracket on the bottom and to do the one on the top? Like, if you're drawing the 10 down, do you put the bracket on the bottom or do you put it on the side of that?
Oh, how about we do this one? Maybe you can ask me when I go with this one. This one's weird because it's just one. So we'll just, how about we ask when we do this one over here? Maybe I'll answer your question when I do that one. Because this is weird because it's 1 and 1. And so then you've got only one that's double shaded out of how many? How many squares are there in the whole thing? 100. So it's 1 out of 100. So then they did the math, where they did the multiplication smoosh. They smooshed them together. 1 times 1 over 10 times 10. 1 times 1 is 1. 10 times 10 is 100. So you got 1/100, and my math should match my picture. So let's see if I answer your question over here. So all I really do is I pick my first one, and that's the one where I go down, and my second one is where I go left to right. It really doesn't matter. I just try to be consistent so I don't mess myself up. So this one, 4/10. So I'm going to go 4 out of 10. So this one is going to be the one that I do 4/10. So I'm doing 4 columns out of the 10. Y'all see what I did? Yeah, no, maybe a little. Because this is 1, this is 2, this is 3, this is 4. 5, 6, 7, 8, 9, 10. I colored in 4/10, 4 out of the 10.
Oh, so that's why but that's not 4 though.
1, 2, 3, 4. No, it's 4/10. 4 columns. 4 columns.
Of the 10. 4 columns of 10.
4 columns of 10. Thank you. Okay. Then this one I'm going to do my up and down, because again I try to be consistent with which one I do every single problem. I try to do the same thing every single problem. And so then this one is going to be the one that I go side to side. So I'm going to do 1, 2, 3 tenths. Now I'm not going to go all the way across. I just do double shading. I'm going to stop there. I'm only going to color over the ones that are already colored. But I'm only going up 3 columns. So, don't. You had 2 other pencils that you were playing with a minute ago. So, I already know, because I had to do 100 square for this, is however many out of 100, and however many are now double shaded. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it says to write it as a multiplication with decimal factors. The first one is done for you. So I need to take this and write it as a decimal. So how is this as a decimal? Tell me.
0.4. No. 0.0. I'm gonna just write it down.
You got what you got?
I got
Awesome.
that too.
Now I can put a 0 in the front. So okay, then I also need to go ahead and work this also to back up the picture. So 4 tenths times 3 tenths, do your smoosh math. Put these together in the same thing. 4 times 3. Top numbers together, bottom numbers together. Don't forget to multiply the bottom. Yes, ma'am. Well, like I've said before, if the picture really doesn't work for you, you really don't have to do it. Today, it's really just, this is how it works. If the math really works, do it. The picture really is just showing you how it works. Okay? Because for you, I really don't like you doing pictures. So 4 times 3. Oh, wait. Are you going to tell me something I was about to point out? What?
Instead of multiplying, just add the 0 to the 10, and then do 3 times 4. But in the 10 plus 20,
Oh.
that's 100.
Oh, yeah. Adding the other 0. Sorry. But see, I was thinking something else because I started to do like the in the problem simplifying, but I don't think that in this case we should do that. Because if we did that, it would change our answer. Because then we would end up with 2 times 3 over 10 times 5, and then we would end up with 6/50th, and then we can't really do the decimal. So let's not, because I saw it and I went, oh wait, so do not do the in the problem simplifying. So I'm glad that we kind of saw it so that I could bring it up. Don't do it. Do not do it. Okay. So, here is a good, yes ma'am. Oh, well, here we have a fraction and a decimal. So we need to figure out what we're going to do. So we need to leave this fraction and then do what with this? Turn it into a fraction. Well, we have 1 and 4/10. How would we write that as a fraction? What would we do? Yeah, your hand was up.
1/10 times 1. No, I thought it was. It's in the denominator 100.
No, it would not be 100 because there's only one number behind that decimal.
1/10 times 1/4.
1 and 4/10. Now, what exactly, this would still be a problem. This is kind of difficult to solve. What can we do with this to solve this? What should we do? Well, it is a mixed number.
No,
You're in the ballpark. Bring it home, Sophia.
oh.
It's on that anchor chart right over there. Keep looking over there. Not mixed, but the other thing that's on that anchor chart up there.
Can I just say
No. Improper. We need to turn this into an improper fraction because right now we can't multiply it like it is. So if we need to turn this from a mixed fraction into an improper fraction. So we could either have done it while we were up here, or we can do it when we're here. So one thing that you can do is multiply and add, because it's on that anchor chart over there that's been up there all year. 10 times 1 is 10. 10 plus 1, 14. Or what you do, since this is 1 and 4/10, the denominator is over 10, pluck out that decimal, and you're stuck with 14. 14/10. You pluck out that decimal. There's only one number behind that decimal.
that's all you gotta do?
There's only one number behind that decimal, so it's tenths. Pluck it out. No, it's not.
I was being sarcastic.
So 1/10
Even though it
times 14/10. So, yes ma'am. No, because there's only one number behind that decimal. If there were two numbers behind that decimal, then yes. But your value takes your number takes the place value of the last number behind that decimal. There's only one. So it's 10. So this one's going to be the one that goes up and down. This one's going to be the one that goes side to side. So when I'm here, boop, 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 boop. This is 1/10. Oh, well, no. Hey, I need to do it the other way around. You're right. That's not going to work. So this one needs to go This one needs to go side to side, and this one needs to go upside down, up and down. Why does this one need to be the one that goes up and down? Ryan, you know.
There's not one above it, and you can't make it go up. And then there's one to the side. There's a graph to the side of the
There's 14 of them, and it's going to take more than one chart. Because one of these is 10, and I'm going to need how many more over here?
4.
4, because I'm going to have to fill up the whole thing. See, right when I did it, I was like, hold up. So this is 14, this is 10, and then I've got to do 4 more over here. Strickland had a brain derp.
What's a brain?
When my brain goes derp.
What's a dirt?
Nothing.
I want to know. I've heard of a dirty face, but I haven't heard of a dirt.
Okay, so there's my 14. And there's my 1/10. Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 14/10. This one is 1/10. So how many of these do I have that are double colored? How many are double colored? 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 that are red and black. Out of a possible 100. 20.
No, because honey. I just thought that.
Because it's still, it's just because you had to take up 2 charts, it's still out of a possible 100.
I thought out of green.
Right, see, you had brain dirt too. So 1 times 14 is 14. 100 and 10 and 10 is 100. And see, again, that's why pictures are not my favorite, just doing the math is. Well, no, you were saying that for this. So, as a decimal, it would be, now it would be 14/100. Because this was 1 and 4/10, because it's a whole and that. 1 whole and 4/10. Yeah.
Can you is this?
Yes. Okay. Pull down page. Let's pull this up. Okay. And then we have the same thing of 6/10 times 1 7/10. I am not. You don't have to do the pictures if you don't want to. You can just do the math. Because I know that doing the squares is not your favorite thing to do. So if you just want to do the math, you can either do fractions or do decimals. But it really, in the directions, are telling you to do both. Okay, 6/10. I'm just going to pull out the decimal. The 7 is in the tenths place. So it's 17/10. So this time I'm not going to use the squares. So 17, I'm going to use it as a scratch paper. 17 times 6. 6 times 7 is 42. 6 times 1 is 6, plus 4 is 10. So 6 times 17 is 102. 10 times 10 is 100. So I have 102 over 100. So this is my fraction, 102 100. So if I have to take this fraction and turn it into a decimal, then 102 with, if I use what I learned about Mr. Dog, 2 places to the left. 1, 2, 1 and 200. And plus, this is improper. 100 into 102. We can go in one time. 1 and 200. Also your fraction. So 1 and 200. I mean, there's more than one way to do it. So, you know, there it is. Okay? So, this, it says, multiply. The first few are done for you. Now you can say, but these are the same. No, they're not. A, B, and C, they're different by place value. This one is 5 times 7/10. And they've got 5 as a whole number times 7/10. So what they did is they've got the whole number 5, which is essentially over 1, times 7/10. 5 times 7 over 10, 35 over 10, and then they take the decimal and they move it in one spot. 35. So it's 3 and 5/10. 5. I'm not laughing. 5/10 times 7/10. So then they turn it into fractions. 5/10 times 7/10. Then they do that little, what I call the smoosh math. 5 times 7 on the top, 10 times 10 on the bottom, 35 over 100, 35 hundredths. 35 hundredths is what B is. So then, here on C, which is not complete, they have 5 hundredths as a fraction times 7/10. So they're smooshing them together. In that blank, you've got 5 times 7. So what should it look like in that blank area? 35. Thank you, Ryan. Why would it be 1,000? Because 100 times 10 is equal to 1,000. Because all I've got to do is add an extra 0. So 1,000. 35 1,000. So what is 35 thousandths? Not 35,000. 35 thousandths. What should that look like? Shadrach, what should that look like?
It should look like a 0 And then what's the 0? And then 35.
So this is tenths, hundredths, and thousands. You are correct. Very good. Okay, so I want you to try to do D, E, and F. Okay, so 6 times 3 tenths gives you 18 tenths. Now if I'm writing 18 tenths, I saw a couple people do this where they were trying to make it like this. That's 18 hundredths. So that's not correct. The 8 has to be in the tenth place for it to be correct. So it's 1 and 8 tenths. So it's 1 and 8 tenths. 6 tenths times 3 tenths. 18 hundredths. That is that one. 600. Isn't this stuff easy? Times 3 tenths. And when I showed y'all the other day, you were probably like, oh my gosh, what is she going to do to us on Wednesday? 18 thousands. So the 8 has to be in the thousands place, which means the 1 has to be in the hundredths place, which means there has to be a 0 in the tenths place and a decimal. So if you have a hard time with, like, do I need to put a 0 there? Do I have to put this there? Do you think you could pull out that place value chart that you got back in first quarter and kind of go, okay, I've got to do thousands. Okay, I'm going to put that 8 in the thousands place. I've got 18. There's the decimal. I've got this here. Oh, 0 right there. Use the tools that we give you to help you make sure that you write your numbers right. Because if your number is not written correctly, it's kind of wrong. So like this, there's a difference between 1 and 8 tenths and 18 hundredths. Wouldn't you say there's a difference between $1.80 and 18 cents? Place value makes a difference. Decimal placement makes a difference. So you have to make sure that you write it correctly. Otherwise, it's wrong. So you're going to have to work on that. Alright. Happy?